Hey, it's Adam with another coding video. This time I'm in the mood for some Python. Let's make a little game. I'm fairly new to Python, but you can't deny that it's popular, especially as a learning language. Part of the reason for that is how easy it is to use. It's almost conversational. Now, there are a number of game engines available to use in Python, but today we're going to be looking at Pyxel. It's a retro-style engine which imposes some of the restrictions that you would have had back in the 8-bit days coding for machines like the Commodore 64. Hey, side note, there will be some C64 coding videos coming in the future. It's pretty fun and I'm excited about it. So Pyxel restricts us to 16 colors, 4 sound channels with several modes and effects, a limited number of sprites and space to hold our levels, but it has a really nice resource editor and is super easy to use. We'll be using Pycharm to build this. It's a JetBrains product. You might know how much I like their tools. Pycharm comes in a free community edition, which is what I'll be using, so I don't get any unfair advantages. Head on over to jetbrains.com/Pycharm. When you get there, hit the download button and choose the community edition. After you get that installed, head over to the Pyxel GitHub page, github.com/Kateo/Pyxel. There's some cool screenshots of the stuff you can expect. If you scroll down, you'll find the How to Install section. You will need Python 3 installed on your system. You can get it from there. If you're running Windows, go there and this is the installer you'll get. Make sure you hit the Add Python 3.8 to Path when you install it. These are the instructions for Mac, and these are the instructions for Linux. On Linux, you want to make sure you install these packages. And this section here where we use pip to install Pyxel is not super critical. You can do that if you want. It installs it globally on your system. But Pycharm kind of likes installing it locally within your project. So we'll do it that way. That way all of your requirements for the project are all bundled in the same folder. You keep scrolling down. After you finish this tutorial, come and have a look at these examples here and further your learning. This page we're on right now, and these are examples is how I learned it. You scroll down to how to use. It gives you examples of how to get started writing your Pyxel program. If you scroll to the second one where it uses the app class, that'll be the more appropriate one for us. You don't have to type that right now. We'll go through that shortly. It has some built-in commands to take screenshots and do recordings and whatnot. You can ignore all of that. The escape button is what quits the app. Our resources, will come to that. Pyxel comes with an awesome little resource editor. Lets you do sprites, tile maps, sound effects, and music. Cool, so once you get Pycharm installed, you want to create a new project. I'm going to call mine Nibbles. We're going to make the snake game in Python using the Pyxel engine. I'm using the virtual environment. It already knows where my Python is installed. If you like, you can inherit global site packages, but as I said before, we're going to go through and install Pyxel into our project anyhow. We can create a main py welcome script. That's fine. Just hit create. Alrighty, it gives you this. This is Pycharm that does this. Gives this little sample program. It says Shift F10 to execute it or replace it with your own code. Press double shift to search anywhere in classes, files, tools, windows. So that's just a tip on using Pycharm. If you press double shift, you can look for stuff. whatever you like. Use a breakpoint in the code line to debug your script. Press Ctrl F8 to toggle the breakpoint. We can click there. That's how you set a breakpoint. So let's run it. It looks like it'll say, "Hi Pycharm." Hi Pycharm. Yay. If you got that far, then you know everything's working. Nice. All right, let's scrap all this. You can keep this top bit here if you like, just to remind you what the keys are. Well, let's grab this code here from the Pyxel site, the one that has the class app class. Let's paste it in here. All right. So you'll notice when we go import Pyxel, it's red. It says no module named Pyxel. Check this out. We can go install package Pyxel. Let's do that. Package installed successfully. We didn't even have to enter any commands. Now, Python is a bit pedantic about white space, about tabs and empty lines above and below classes and functions. So you'll see these yellow squiggly lines underneath things that says expected 2 blank lines, found 1. So if you put another blank line above the class, it's happy again. This one will be the same thing. Expected 2 blank lines, found 1. Bam, there you go. In other languages, some people like to use 2 spaces for tabs or 4 spaces. In Python, they want you to use 4 spaces. That's how it is. It's probably part of the reason that Python is easy to learn, because it forces you into certain code standards, and every sample that you'll find on the internet and tutorial will be using those standards. Now what this does, import Pyxel, imports our Pyxel engine into our program. Class app is our main app that will run our program. You might think of it as in C++, we had our main function. It contained our main game loop. So class app, and then down the bottom we call app. That's what actually kickstarts our program. Let's put a little comment here. Kickstart our program. When you want to create a function, you need to define it. So you go def. This one here, underscore init, is the constructor for this class. So whenever you instantiate this class, it calls this constructor and sets itself up. These other functions here underneath app, they can be called either internally or externally against this class. That'll become more obvious as we add more classes to the game. Anyway, let's get into it. So Pyxel init is how we create our screen, 160 by 120. That's pretty small. So we might increase that a little bit and go 192 by 128. Because we want to use 20 pixels for each of our, we want to use 8 pixels for each of our sprites. So our dimensions of our window need to be multiples of 8. Now that'll actually make a really small window. So what we want to do is add some scaling to it. Scaling that small window by 8 makes it a nice fit for a 1080p window. Let's add a caption. I'm going to call it nibbles. And let's set the frame rate. Now let's run it. It should give us a window. It does. And this little orange box goes across. That's the sample that they provided on the Pyxel website. Press escape, you can quit. All right, self.x, so that's the x coordinate it's using to move that box across. And then Pyxel.run is what the engine uses to run its loop. And each time it runs through, it'll run update, and then it'll run draw. So update, it looks at x and sets it to x plus 1 modulus of pixel.width. So that just makes it scroll across and then wrap around to the left-hand side once it gets to the end. On the draw function, it clears the screen and then it draws the rectangle. The x coordinate, the y coordinate's just fixed at 0, and that's width, height, and color. If you hang your mouse over rect, it gives you what those are: x, y, width, height, color. If you also have a look at the Pyxel site, keep scrolling down past all of this stuff to the API reference. It tells you all these things. So init, width, height, caption, scale, FPS. We didn't do palette. We already know the quit key is escape. We're happy with that. We're not doing full screen. If you're looking in graphics, we'll find rect. There it is, rect, x, y, width, height, color. So everything that Pyxel can do is right here on this page. We don't want that square rolling across the screen, so let's ditch it. Let's ditch the rectangle. Let's ditch the X out of update. Now, because you're leaving update empty, for now, let's just put pass in there. Pass makes sure update isn't empty, but all it'll do is just fall through. Let's also get rid of self.x in our constructor. Let's check out what draw is complaining about. Method draw may be static. That's because it does nothing. Forget about that for now. We'll be adding more stuff here later. Now we want to create some sprites, some assets. So let's create a folder. Right click on nibbles, go new, directory, and I'm going to call it assets. That's where we want to save our stuff. Now we're going to load up the resource editor. And the easiest way to do that is down the bottom here, click on terminal. It automatically put us in our nibbles folder. We want to be in the assets folder. Now we want to write Pyxel editor space and then the name of our resource file. Let's just call it resources.pixres. That's the file format it uses. All right, so this is the cool resource editor. It starts in the Sprite editor. This is our color palette down here. These are all the colors you can use. You can actually declare a different palette if you want, but we'll just use this one. This is the tile map editor. You use sprites from the first tab to build up a tile map. We'll use that later to build our level. This is the sound editor. You can create sound effects and even the instruments for your music. And here's the music editor. As you can see, there's 4 channels for audio. We'll use 2 or 3 of those for our music, and we'll just use 1 for our sound effects. You want to keep them separate. If you try and play sound effects in a channel that music is playing in, it'll stomp all over it and make your music sound weird. So we'll just keep it separate. All right, first thing we want to do is create some sprites. I want to use this first field for our snake, and we're not going to make it just yet. So over here, let's click on the second field. And up here you can see the first square starts at 16 by 0. because the first lot was 0 to 7 and then 8 to 15. Next lot is 16 to 0. That'll be important later on. Now we want to make an apple. You can either grab red, grab the fill tool, fill the whole thing. We're not using all 4, we're just going to use 1 here. Or you can grab your red, grab your pencil tool, and draw something. I don't know. Apples are a bit hard to draw in pixels. We can color that in. Put a little green leaf on the top. Plonk, plonk. There you go. There's a wonky apple. Let's see if we can make him a bit nicer. I mean, that'll do. That'll do. All right, so let's save that. Just click save. And I'm not going to close this. We'll come back into it a few times. So we'll just minimize it out of the way. All right, in our assets folder, you can see our resources file there. We're going to want to load that resources file up here in our app constructor. So right after our Pyxel init, let's go pyxel.load assets / resources.pixres. Now we've got our resources loaded. That means our game can see our apple sprite, but it doesn't know what to do with it yet. So we're going to want to create a class to store our apple. So under our import, remember we need 2 spaces between everything. We're going to create a class apple. Put a colon at the end of class and function definitions. So the first thing you need to do is put the constructor in. So it's underscore init. Self, it always has self in there, but we also want X and Y. When we initialize our apple, we want to tell it where to be on the screen. Self.x equals X. Self.x means that's a variable inside of this class. So when it's instantiated, if you call X on it, then that's the X related to that instance of apple. Self.y equals Y. These ones here that don't say self dot are coming in on the constructor here. So we pass them as we call the apple later on. You'll see it. Self.w, this is the width. 8. Self.height equals 8. Now, we're going to need a draw function in here. So we can call it later on and the apple can just draw itself. And to do that, we're going to use Pyxel.blt, not the sandwich, short for blit. Self.x, so the x coordinate, self.y. 0 is the image to use in our resource editor. So it's using image 0. There's a number of images we can use. And we're using image 0, and we're going to need the top left coordinate, which is 16 by 0. So image 0, U and V are the coordinates for where it lives in our sprite map. So 16 and 0. And then it wants width, so self.w by height, self.h. There we go. That's how you blit a sprite to the screen. Now our Apple class will need a couple more functions, but we'll add them later. Let's put a comment up on the top here. Remember, you always want to keep 2 spaces, including away from the comment above your classes and functions. So Apple class handles drawing and moving the apple, as well as checking if anything is on the apple. Snake ate it. So we'll do the moving and the collision checking later. For now, we just want to draw it to the screen. So before our run, we want to create an instance of that apple. So inside of our app, we're going to create a self variable called apple, lowercase, equals apple. That's the name of our apple class. And then remember, it wants an X and a Y coordinate. So let's just put it at 64 by 32. Now that's not enough to draw our apple on the screen yet. Let's come down to our draw function. Now after the clear screen, you don't want to be putting draw things in front of clear screen because it'll just blow them away straight away. Let's do self.apple.draw. That's the function we created just before. Now if we run it, I expect to see a nice red apple in the top left corner of our game, or it's kind of middle towards the top. There it is. That's the apple I just drew. It's kind of plump and round looking, isn't it? Let's see if you can draw yours better. Nice. Next thing we want to do to make our game a bit more interesting is start creating our snake. So we've got something to move around and something to eat our apples with. So we're going to need our resource editor again. Let's go back to the first tile in the Sprite Editor and start drawing our snake. Now I want to use this top left section here for the body sections. And then we're going to need 2 heads. One we'll put facing right. Because Pyxel doesn't seem to have any rotate functions, we can't rotate a sprite, but we can flip it. So if we do one here facing right, then that can handle right and left. If we do one here facing down, then that can handle down and up. So let's do our body section first. Use some green. You can do it plain like that, but let's put some patterns on here. Do some little circle things. If you put them on the edge, when they tile, they'll join up. It'll look like circles. That'll look like kind of a carpet if we tile it all up. Let's put some more around the edge here. All right, that can be our body section. Put a dot in the middle. That look weird? Maybe. You draw it however you like. Now, our head section, we want it to kind of match the body section because it's going to be up against it. So let's use some dark things here. Pick our color. Dark there, there, there. Light green there. Now, we want it to kind of taper in like a head. It's going to look weird, maybe. Let's give him a bit of a red tongue sticking out. Maybe a couple of eyeballs, eh? Oop, not really close together, that'll be weird. Let's grab our fill color. Let's fill the head in first. Give him a couple of eyeballs. There you go. Right, so we need to duplicate that there, down here. So hop to it. You saw me do it. There we go. So it looks a bit weird in here, but hopefully it won't look too weird in our game. Save it. Now these, well, we're going to need to know the coordinates for each of these squares. So 0, 0 is our body section. 8, 0 is our right-left head. And 0, 8 is our up-down head. So minimize that. Plonk. We're going to want to start building our snake class. So underneath Apple, leave some space, remember. We're going to call it, because it's not going to hold our entire snake, our snake's going to be built up out of sections. We'll call it snake section. We'll give it our comment first. Snake section class handles drawing snake sections, including orienting the head. Also checking if something intersects it. Snake crashed into itself. We'll do the collision detecting later, but we'll just note it down there so we know we're coming back to it. Start with our constructor. We're going to want an X, we're going to want a Y, and because we need to know if we're dealing with our actual head section to know which sprite to use, we're going to put another variable in here called isHead, and we're going to set a default value of false. So that means if we create a new instance of a snake section and all we do is give it an X and a Y, then it will assume that it is not the head. If we create our first section, we want to say isHead equals true when we instantiate it, and then that section will know that it's the head. So we create our variables, self.x equals x, self.y equals y, self.w, so we need the width and the height again. We know they're 8 pixels. Self.height equals 8, and self.isHead equals isHead. There we go. Now let's do our draw function. So def draw self, and because we need to know which direction we're heading to know how we need to manipulate the head section. So we'll pass in the direction every time we do the draw function on the snake section. Now this function is going to be a little bit longer. Try and explain it as we go along. We're going to need some temporary variables in here because the way we're going to flip the head vertically or horizontally is by manipulating the width or the height. We'll turn them into a negative value and it'll flip it. Height equals self.h. So we're going to call them in temporarily so we can manipulate them. Sprite underscore x equals 0. Sprite underscore y equals 0. We're going to use these variables to manipulate the x and y for where the sprite lives on our sprite map. Now, if this is the head section, then we need to change and flip the sprite depending on the direction. All right, so if self.isHead, So if the draw function's been called on the head, then check the direction. First, we need to create a label for our directions. So our game needs to know which direction our snake is heading, and I like to use nice labels instead of just using 0, 1, 2, 3 to denote directions. And in Python, if you want to use an enumerator, you need to import enum. If you spell import correctly, it works better. There you go. Now up the top here, let's create our direction labels. So snake direction labels. Now the way you create an enumeration in Python, I'm going to call it direction. It's enum.enum. And then we're going to declare them in here. So right equals 0, down equals 1, left equals 2, up equals 3. You don't need to do this enum method. You could just put them here as variables out in the outer scope here. Just put these right here and then call them directly. I like to put them in an enumerator so that I can type direction.right, direction.down. It just keeps everything separate and really tidy. So back down to our snake section, we're in the middle of doing if is head, and then we want to do if the direction that was passed in to the draw function is equal to direction dot right. See how easy that is to use? Then we want to do sprite.x equals 8, because we know the head's going right. We know that sprite is at 8, 0. Sprite.y equals 0. See, I'm putting semicolons on the end of these. That's from writing all sorts of other languages. Sorry about that. Don't put semicolons on the end of your lines in Python. So if direction is equal to direction.left, you might have noticed that we're declaring this sprite xy up here, and then we're instantly changing them down here. That's for a reason. We need them declared up here so that we can use them down here after all of these if statements. So these will be used down the bottom regardless of whether we're the head or not. So sprite.x equals 8 in the left direction. Sprite.y equals 0. So using the same sprite, but we want to flip it around. So we want to do width equals width times -1. And what that'll do is the width is 8. That'll convert it to -8. So when we go to draw our sprite, Pyxel will know to flip it horizontally. So if direction is equal to direction.down, what do you think we should do here? For up and down, we need to use a different sprite. So sprite.x equals 0. Sprite.y equals 8. Now, if direction is equal to direction.up, then we need those same x and y coordinates, but then we need to flip it vertically. So height equals height times -1. All right, so underneath all of this if stuff, go back 2 notches, so we're also underneath this is head. We're going to call our blit. So pyxel.blt, self.x, self.y. Self.x and y are the positions for the snake section. 0 is the image number, remember? So it wants X, Y, image, U, V, WH. U and V are the sprite locations. So sprite X, sprite Y, and then width and height. Width, height. There we go. Now there's another function we need to put into the snake section, but we'll do that later. That's to do with collision. We need somewhere to store our snake sections, to build our snake. So inside of our app, we can create a couple of arrays. So before pyxel.run, let's do self.snake equals an empty array. Just put a comment on that. Store the snake sections. You need to put 2 spaces after if you're doing an inline comment. If you don't, it'll tell you about it. Alright, so we need to instantiate some snake sections. So let's just do self.snake.append. Because it's an array, we can append snake section. So we're adding a snake section to it. And we're going to start it at 32 by 32. And this first section will be the head. Now you can just type true in here, but it's nicer if you put isHead equals true. Then it's absolutely clear what this does. If I add another section, self.snake.append snake section. Now we want to put it to the left of the last one, and because they're 8 pixels wide, let's go 24 by 32. Because it's not the head, we don't need to say anything about isHead, because we're up in our snake section class, we're assuming that isHead is false. Self.snake.append snake section. Put it 8 pixels to the left of the last one. There we go, 3 snake sections. That'll get us started. Now we also need to store the direction of the snake. So self.snake direction equals, we'll initialize it as right. In Python, they recommend you use this snake case, which is all your variables should be all lowercase and use an underscore between words. In C++ and most other languages, I like to use camel case, which would look like, snake section or snake direction. So first letter is small and each subsequent word starts with a capital. If you do that in Pycharm, it'll remind you that you should be using the underscores. Just part of Python. Now one more thing to draw our snake to the screen. We need to update our draw function. Now it's not like the apple.draw. Apple is just a single item. Our snake section contains many items and we don't know how many it will be because the snake will keep growing. So what you want to do is loop through every piece of our snake and call the draw function on that piece. So each individual piece will draw itself. Easiest way to do that is to use a range loop. So for s in snake, so it's a range for loop. So s.draw self.snake direction. Remember, we want to pass snake direction through. Self.snake here, it was red. When you're calling a variable of this class that you're in, you need to say self.snake. S is going to hold each item in self.snake as it loops around, and then we can call functions on it. All right, I think that will draw a snake. There he is. Stumpy little snake. He looks all right. His head's not too bad, right? He's ready to nom on that apple, but he can't move yet. So let's move on. Look, let's work on moving that snake. Now we can't do the move function in our snake section because this snake section class doesn't know about all of the other snake sections. We need to do it in our app. So let's do it under our draw function. I'm going to define a function called move snake. Pycharm always puts self in there for you. Now later on we're going to be capturing input so we can tell the snake which direction to go, which means we'll have to come back in here later to change directions. But for now, let's work on, first we need to move the head, and then we need to move all the tails sections after it. So to move the head, we need to first store the location of the head so that our tail sections know where to move on to. So we're going to create a couple of variables here. Previous location x equals snake 0. The index of 0 is always the first section. Snake.0.x. And then previous location underscore y equals self.snake snake 0.y. All right, now we need to check the direction so we know where to move our snake. So if self.snake direction is equal to direction.right, then self.snake 0, which is always going to be the head, .x plus equals self.snake 0.width. So it'll move its whole body width, it'll move its whole sprite width each turn. Right, so we're going to want to do that for all the other directions. So let's do a little bit of copy paste. So we've got right, left, oops, make sure they line up properly, down, up. Now let's fix them. Left will be similar to right, only instead of going plus, we'll go minus x. Down, we'll be working on y instead of x. And up, we'll be working on y, but it'll be going minus. Right, so that'll be the head moving. Now we need to move the tail. Put some comments in here so we don't get lost later on. So to move the tail, we need to loop through all of the rest of the snake. So let's use our for loop again. Self.snake. Now, this for loop will also include the head section. We don't want to move the head section again, so we're going to check if s is equal to snake 0, then continue self.snake. Sorry, I keep missing out that self there. It's because the project already coded that I'm referring to. I had snake up in the outer scope instead of inside the app class. I just made a decision while I was recording this to put it in the app class. All right, so continue. We'll skip the rest of this loop and start on the next one. So let's get into it. Current. Oops. We want to store the location of this snake section. X equals s.x. Notice I did the camel case here, and it's complaining. Current y equals s.y. Now s.x equals previous location x, s.y equals previous location y. So we're storing the x and y of that snake section, and then we're moving the snake section to the previous location, which on the first run will be where the head was. And then we want to update the previous location. So previous location x equals current location x. That's why we stored it up there. Previous location y equals current location y. Alrighty, so that'll move the head and the tail. Alright, so before this will do anything, we need to call the moveSnake function. We're going to do that in update. Update's going to get a lot longer later once we get our timing and whatnot. It's going to be moving things and checking collisions and adding scores and keeping track of time and whatnot. Just for now, just so we can see it happening, self.moveSnake. So the only thing update does is move the snake. Now when I run it, because there's no timing, it'll move that snake as fast as it possibly can. So I might not be able to show you him moving. Yeah, he zooms straight off the screen straight away. You can see he's not there. If you run your own game, you'll see him zoom straight off. We don't have any collision detection, so he also didn't eat the apple. So let's work out some timing and a speed variable. To do timing, we need to import something else into Python. We need to import time. That sounds handy, right? Now we need a variable for speed. So in our app class, let's put it underneath all the snake bits. Self.speed equals, we'll start it at 1.5. Yeah, we're going to need some time variables here. We're going to need self.time last frame. And we're going to initialize it as, just kick it off. So time last frame will be how we track when we last moved, what time the last frame was. Self.dt, we use dt for delta time to keep track of how much time has passed. Self.time since last move. Now, this is what's going to trigger our snake actually moving. Now down in our update function, we're going to need to do some time stuff before we move our snake. So we're going to create a temporary variable in here, time this frame equals time.time. Remember, our update happens every time the game loops around. And we're just going to fetch the current time at the top of the update loop. Then we're going to get the delta time. So this is the time difference between the last frame and this frame. So delta time equals time this frame minus self dot time last frame. That gives us our delta time. Then we want to update our time last frame equals time this frame. Then we want to go self time since last move plus equals delta time. Now, before our move, we want to do a check to see if enough time has passed. So if self.time since last move is greater than or equal to 1 divided by self.speed. And we want to tab in our move snake so it's underneath this if. Alright, so our snake should step across the screen 1.5 times a second, I think. First thing we need to do when we are actually going to move is reset our time since last move. Self.time since last move equals 0. So that can start counting up again. Alright, let's test this. There he is, moving along the screen. about 1.5 times a second. We can't do anything with him. If we let him go, he'll just go off the screen and disappear. Cool. So we've got our apple, we've got our snake, we've got some timing so our snake doesn't move super fast. We can adjust the speed later on by changing this value here. What should we do next? I think we need to be able to eat that apple. Now, if we're going to eat the apple, then our apple needs another function. We're going to build an intersects function. Intersects is an idea I got from SFML when we were doing our C++ stuff. Basically, you call intersects against the apple and you give it some coordinates, and it'll tell you if the coordinates you gave it are where the apple is. So we're going to use u, v, width, height. Using u and v so we don't get confused with x and y. U and v will be the coordinates that we want to check against the apples x and y. So we're going to create a boolean here. So is intersected. And we're going to say it's false to start with. Now we're going to do a big funny looking if here. We're going to put it across multiple lines because it's a little bit big. And we're going to have, if something and something and something. So we need to wrap it in some brackets. Now, if u plus w is greater than self.x, so if the left-hand side plus the width is greater than the x coordinate of the apple, so if it's just inside, if it's inside the apple, and self.x plus self.width is greater than u, and v plus h, so the v coordinate, which would be the y coordinate that we're checking against, plus the height is greater than self.y, and self.y plus self.h is greater than v. So it's basically checking if this x and y coordinates are somewhere inside of that apple, anywhere inside of that apple. So a big if statement, we're going to put our colon at the end of the thing there. It looks a bit funny. We go is intersected equals true. So if all of this is true, then is intersected equals true, and we're going to return is intersected. If one of these is false, then it will remain false and it'll return false. Right, so we need to create another function here for our update to call whenever we move our snake. We're going to create our collision function. Let's put it above move snake. Put it wherever you want. It doesn't matter, as long as it's inside this app class and it's tabbed in. Check collisions. So this function is going to check all collisions. Ultimately, it'll check whether the snake has hit the apple, it'll check whether the snake has hit itself, and it'll check if the snake has hit a wall later when we make walls. So the first thing we want to check is apple. So if self.apple.intersects self.snake, we're only interested in the head, so snake 0.x self.snake 0.y self.snake 0.width self.snake 0.height. So if the snake intersects with the apple, then we want to do some stuff. First thing we should do is increase the speed, right? Self.speed plus equals self.speed times 0.1. So each time we eat the apple, we'll increase the speed by 10%. Now something else we want to do is increase the size of the snake. And to do that, we're going to use a variable. In here, we'll update that variable. So temporarily, come back up to our app constructor. And in here, after our snake direction, keep all the snake stuff together. On self dot sections to add. I'm going to initialize it as 0. Later on, we'll update our move snake function so that it checks if we need to add more sections onto the snake. All right, so back in the check collisions, under Apple, we're doing self.speed plus equals, so we're increasing the speed. We also want to do self.sections to add. Let's add 4 sections to him every time he eats the apple. Now back up here in our update, if it's time to move our snake, then after we move it, let's do self.check collisions. We don't want to run it up here because it'll run check collisions every single frame. We don't need that. We only need check collisions every time we move the snake. So we run it there. If we run our game now, I expect to see, if we eat the apple will stay there, but our snake should go a little bit faster. But before we do that, let's have a look at our move snake and we'll add some sections to it. So before we move anything, we want to go, do we need to grow the snake? So if self.sections to add is greater than 0, so if there's any sections to add, then self.snake.append, we want to add another snake section. And we want to add it to the same location as the last part of the snake. So snake, to get the last part of an array, we can go -1, it's the last index, .x, and snake -1.y, remember self.snake. And then we also want to decrease the sections to add, otherwise it'll just continuously add them. Sections to add -=1. So if we're adding a section and then taking one away from the sections to add. So each time the snake moves, if there's sections to add, it'll add 1 section. All right, let's try it. There's our snake moving along. It's eaten the apple. He's gotten faster. And he's added 4 sections. Nice. Next, let's make the apple move. Once we eat the apple, it should move, right? This is a little bit more complicated than you might think. What we can do is create a new random location for the apple, but we don't want the apple to appear inside of the snake or inside of the wall. So first we need to generate a random new location for our snake, and then we need to check if that new location collides with we need to generate a random location for the apple, and then we need to check if that new location is inside the snake or inside a wall. First, let's go to our apple class. Before we do the tricky bits, let's go to our apple class. Underneath intersects, we're going to want another function. It's called move. It's going to want a new x coordinate and a new y coordinate. And all we're going to do is go self.x equals new x and self.y equals new y. Now down in our app class, we're going to need another function here to move the apple. I'm going to put it above move snake. Move apple. This is what's going to do all the calculations for the random location and checking whether the new location is good or not. The apple class can't do it itself because it doesn't know about the snake or the walls. We have to do it here. Now, because we're using random numbers, we need to import something. What do you think we import for random numbers? We imported time when we needed time. We're going to import random, baby. All right, come back down to our new move apple function that we didn't do anything with. Let's put some stuff in it. Let's type what we're going to do. Select a new random location for the apple. Make sure it is not in a wall or in the snake. So we're going to start with a Boolean. Good position equals false. We're just going to assume it's false right now. Now we're going to create a while loop here. While not good position, do some stuff. We're going to create our new random x and y coordinates. So new x equals random dot. We're going to use a rand range. So we can start at 8. Our walls are going to be 8 wide, so we don't want this. If we're going to have walls completely surrounding the game field, so let's not even bother trying to put the apple in the outer 8 pixels because we know it's not going to work. So 8, and then the width minus 8. So the width of the screen minus 8 is 184. So 192 minus 8 is 184. You got it. You're smart. And then 8 is the interval for the range. So it'll find a number between 8 and 184 that's a multiple of 8. It's pretty handy. New y equals random dot rand range. Same again, but we're doing 120 because the height of our game is 128. Now we're going to assume that our good position is true here, and then we're going to test that. So because we don't have any walls, we're only going to check for the snake first. So check snake. To do that, we have to iterate through every part of the snake, unfortunately. So for s in self.snake, we're going to do that same if statement we did in the apple when we were checking for intersections. So if new x plus 8, that's the width of our apple, is greater than s.x, and s.x plus s.width is greater than new x, and new y plus 8 is greater than s.y, and s.y plus s.height is greater than new y. So if all of those things are true, then we know that the new apple location is inside of a snake section. So good position equals false. Now because we're inside of that loop, we should break out of it as soon as we realize it's a bad position. So break should get us out of that. Otherwise it'll always loop through every single section of the snake, even after it's found a bad location. Let's just help it do its job more easily. So we're done checking for the snake. We're not going to do the wall yet. Let's just put the comment in there for later. Now, if the position is good, move the apple. So if good position, self.apple.move new x, new y. That's that. Move apple. Now, when do you think we should call that? Under check collisions, if we've had a collision with the apple, after we've changed the speed and add sections, let's move the apple. So self dot move apple. I think that'll run. Got warnings up here. What are they? Let's check them. Ah, I didn't leave enough spaces up there. There's another warning. Is it telling me about a typo? We don't care about that. So you'll see it's kind of complaining about typos because PixRes isn't a word. What you can do, hover over it, go more actions, save PixRes to dictionary, and then it'll stop complaining about it. And now that little thing's gone and we've got a tick in the corner. No problems found. Right, let's run it. See if our apple moves. Bam, it did. Now we can't move our snake to chase the apple, but we know it moves. Nice. So I think next thing to do, obviously, is to make our snake be able to change directions. For that, we're going to need some inputs. Luckily, we can use Pyxel for that as well. Now, one thing I learned about inputs for these snake games is because it moves so slowly, sometimes it's a bit weird to be pressing up or down to change the direction, but it doesn't happen right away because it's not up to the next step in the move function. And sometimes when you want to do a quick turnaround back the other direction, you know, if you're heading right and you want to go left, you got to go up and then left. It's really handy if you can cue those two key presses. So you just want to go up left real quick and then the snake will just do it. So what we need for that is an input cue. And to do a cue, we need to import something. We can't just use an array for an input cue because we want to add the new inputs to the end of it and then pop the last input off the front of it. Now it's popping things off the front that you can't normally do with arrays. You need a deck. And to make a deck, you need to import collections. That will be the last import for this game. So down in our app class, down where we're declaring stuff, let's put it under time. Let's go self.input queue equals collections.deck. Now deck's a weird word and it looks like you should say it as DQ, but it doesn't actually say DQ, does it? Because you spell Q as QUEUE. Actually, I think some versions of English spells Q that way. Anyhow, what it stands for is double-ended queue. That means you can pop things off the front and the back of it. Store the direction changes so the player can easily chain them. All right, I reckon we need a function to handle our inputs. Now I think it's going to be a big function. Let's put it down here under these move ones. The big ugly ones out of the way. I want to define check input. Now you want to check the direction keys. We're going to use the arrow keys on our keyboard. So if Pyxel dot button Pyxel dot key right, we want that one there. So if you're pressing the right arrow key, first we want to check if there's anything in the queue. So if len, that's the length of self.input queue, is equal to 0. So if there's nothing in the queue, then we want to add something to the queue. But first, if you think about how your snake game moves, if you're heading left, you don't want to be able to hit the right key because the snake would just crash into itself straight away or try and go back through itself. That's stupid. You don't want that. Let's just stop the player from being able to even do that. silliness. So if snake direction is not equal to direction dot left, and we also don't want to queue up the same direction that we're already going. If snake direction is not equal to direction, oops, spell it correctly, dot right, self dot input q dot append, put something on the end, direction dot right. There we go. Now we're going to put an else here. Notice it's underneath the if length of q is equal to 0. So if there's already stuff in the queue, we want to do something a little tiny bit different. We want to check self dot input q -1. So if the last item in the input queue is not equal to direction dot left, so it's the same as the one above it, only instead of the current direction, we're checking the last item in the queue. And self dot input q -1 is not equal to direction dot right. Then do the same thing again. So append it to the end of the queue. So we have to do all of that for each direction. So let's get some copy and paste going on here, hey? It's important to make sure you get your cursor back to the right place before you paste stuff in here. Now, let's use an else if. So if you press key right, else if you press key whatever, left. Now an else if in Python is an elif. Seems weird, but that's what it is. So this one will be key left. And we want to check the opposite directions. So right, left, left, right, left, left. Now let's copy this one because it's already got the elif on it. Back, plonk. Let's do down, key down. All right, so we want to make sure it's not going up. No, it's not going down. Before we allow it to go down, I want to check the end of the queue to make sure it's not going up and it's not going down before we let it go down. One more. Up. So have key up. Make sure it's not going down or up before we go up. Down or up before we go up. All right. So this is our input. We need to call this, of course. Where do you think is a good place to call that? In update, up here after all the time stuff. So we can call the input every single frame. We're not going to do it just when we move the snake. We're going to call every single frame. So that way the player can queue up his moves before the snake even takes its next step. So self dot check input. All right, so we've got a warning down here. It's probably about empty space again. There we go. Let's get rid of that. Green tick. Now we're changing that direction variable, but are we doing anything about it? So in our move snake function, the very first thing we should do before we even grow the thing do we need to change direction? So if the length of the input queue, we're just going to say that. So if length input queue, that means if input queue is greater than 0, it will be true. We want to do self.snake direction equals self.input queue dot pop left. Now think of a queue as a horizontal string of items. The first item is on the left and the last item is on the right. As you append things to it, you add them to the right of it. What this does is it pops the left item, which is the first item on the queue, and puts it into this variable here. So it removes the first item from that queue and puts it in that variable. And that's how a queue works. You add things to the end of it and you take things off the front of it. All right, I think our snake will be able to change direction now. Let's give it a whirl. Here he goes, down, right, up, left. And if you did your math properly earlier, then the head should be rotating properly as well and always facing the right direction. Let's eat an apple. Now we can actually chase the apples. Now there's some problems. The snake can leave the screen. And he can crash into himself and he doesn't care. He just goes straight through himself. So we need to, let's take care of the collision with himself first. So remember we created that function check collisions. We're going to add a little bit more to it. So check collisions, every time the snake moves, it's going to check for collisions, check if the head's crashed into anything. We're already checking for the apple. We're going to check for the tail of the snake now. For s in self.snake, we're doing that for loop again. We don't want to check if the head has crashed into the head. That is silly, because that will happen instantly. Remember the for something in something loop will loop through every single item in that array. We don't want to look at the head, so we just check if we're looking at the head and then just bypass that loop. So if s dot intersects right, we need to create a function in our snake, the same as the apple, for intersects. So apple's got this intersects function here. Let's grab it, copy it. Now down in our snake section, underneath draw, make sure you go back, get your indentation right, paste it in. It should be good to use straight away. So up here, back where we were working in check collisions, snake tail, we want to go if s.intersects self.snake 0. I'm just going to copy that into the clipboard. .x self.snake 0.y snake.width snake.height. So if it intersects, then do something. Now, what should we do when a snake crashes into itself? We should end the game. We don't actually have a way to do that right now. What we need is some game states, so that we can change the game state from running into game over. So back up the top, let's create another enumeration for our game states, just some handy labels. Game state labels. Remember, it's a class. Game state enum.enum. Now we're going to use running 0 and then game over as 1. Okay, now down in our app class, we're going to want a current game state variable. Let's put it kind of up the top here after we load our resources. Doesn't really matter, I just want to put it up there. Current game state equals game state running. Okay, now back where we were with our collisions, back where the error is because we haven't finished that if statement. So if the snake has crashed into the tail of the snake somewhere, we want to go self.current game state equals game state dot game over. Now that doesn't do anything at the moment because we're not checking current game state. So let's do that. In our update, I think at the very least we should stop moving our snake. So above this if statement we've got here, we're going to wrap it in another one. So if self dot current game state is equal to game state dot running, I'm going to tab all of this stuff in. If you select it, select all of that and then just press tab. It'll tab the whole lot in. So now every time the update is run, first it'll check if the game is running, and then it'll check if it's time to move the snake, and then it'll move the snake and check collisions and whatnot. We're leaving the input outside of this, so when the game is in the game over state, we can still do stuff, start it again or quit or whatever we need to do. So now, if we crash our snake, boom, he stops moving. We know that the game state has changed from running to game over. Let's actually do a little trick here just to show that a bit more clearly. So in our draw function, let's put pixel.text at 10,1114 string of self.currentGameState. We'll make it color 12. If you look at pixel text, it wants XY, the string, and then a color. I think you can leave the color out and it probably just makes it white. So if we load that now, you can see in the corner it says game state running. If it crash, it changes to game state, game over. It's a handy little debug tool there. Now what should we do when it's a game over state? We should allow the player to restart the game, right? To do that, we should build a function that basically resets all of these things. So underneath our constructor here, before our update function, let's create a new one. Start new game. First thing it wants to do is change the game state back to running. Then we want to reset our snake. To get rid of everything in our snake, we go snake.clear, self.snake.clear. We want to add those initial snake sections again. Blam. We want to set the snake direction and the sections to add and the speed and the last time and the DT and the time last move. So we basically want to do all of those again. We also want to reset the input queue. So if the player's queued up a whole heap of different inputs, We don't want the snake to go off on all by itself when we start a new game. So input q.clear. We also want to move the apple. Start new game. So when should we call start new game? That should be in our input function, right? Let's put it right at the top. So if self.currentGameState is equal to GameState.GameOver, we're only going to be worried about this key if we're in game over state. So if Pyxel.button Pyxel.key enter, let's use the enter key. Self.start new game. I think that'll work. Let's try it. Alright, snake's moving around. Let's crash. Bam, we're in game over state. If I press enter, everything's reset. We're back to running. Our snake is small again. The apple moved. Everything's reset. Nice. What do you think we should add next? I think we need some walls so our snake can't go out the sides of the screen. We're getting pretty close to having a complete game here. Now for the walls, we're going to need our resource editor. First, we're going to have to create a sprite to use in our tile map for the walls. Now I want to do it on the next frame over here. I want our walls to be white. And just to make it look a bit different, let's put a darker edge on it to make it a little tiny bit of a 3D effect, I guess. Now it looks like kind of like a tile. Now, if we go to our tile map, it automatically fills with whatever the very first sprite is. So it looks like a big carpet now. We don't really want that. Let's just pick a different sprite. Fill the area with that. We need to move across a bit more. Fill some more. You can see the big map over here changing. We could have avoided that by not using that first sprite. Just left it black. Doesn't matter. Right, because of the size of our game is... What did we make it? Check, check, check. Our window is 192 by 128. Our sprites are 8 pixels wide. So 192 divided by 8 is 24. 128 divided by 8 is 16. So I want our level to be 24 by 16 sprites. So each one of these squares is 16. So we want 3 of these squares, right? 8, 16, 24. Let's pick our white tile. Get off the fill tool. There's a undo button here. Look, Control Z. What I want to do is just use the draw tool and just start drawing them on there. I'm just going to do a square around the outside of the game field, but if you feel like you want to put walls on the inside as well to make the game even more difficult, then go for it. Scroll across. Remember, we need 3 wide. There we go. Now what's important here is the ID of the sprite that we used for the wall section. We're going to need that later on for checking collisions. So if we look over here, they're numbered 0, 1. Sorry, back at the start. 0, 1, 2, 3. So this is the fourth sprite along, right? 0, 1, 2, 3. Right, let's save. Now we're going to want a level class just so that it can draw itself and know all of its dimensions and whatnot. Let's create it. Let's put it up here above the apple. Remember to leave enough space. Now I'm only going to do one level for this game, but maybe as homework for you guys, you could draw extra levels on the tile map and update this class to be able to load different levels. Now, the level class will want variables for the tile map. The tile map is 0. Self.u. These are the locations the tile map starts. Self.v equals 0. Self.width equals 24, remember? Self.height equals 16. Now we're going to want a draw function, and it's going to use Pyxel.bltm, so blip map. And we're going to blit it to the top left corner of 0, 0. Self.tilemap, self.u, self.v, width, height. Alright, so whenever we call this draw function on our level class, it'll blit that level that we drew in the tile map on tile map 0 straight onto the screen. Now, because it's a class, we need to instantiate an instance of it. So let's put it under the game state. Self.level equals level. Now, all we need to do is go to our draw function and draw it. Where's draw? There he is. Now I think we should draw the level first. So it's first thing on the page, everything's behind it. Everything's in front of it. Level.draw. I think that'll just draw our level straight away. Bam, look at that. Now we don't have any collision with it yet, so our snake can still roll through it. So let's sort that out. Here's our collision detection. Now, we're checking if we've collided with the apple. We're checking if we're colliding with the rest of the snake. Let's check the wall. Now, if Pyxel.tilemap 0.get, now this gets the ID of the sprite that's at the location that we're going to give it on that particular tile map. So self.snake0, we're only interested in the head of the snake, .x divided by 8, snake 0, .y divided by 8. It deals in units rather than pixels. 3 was our ID of our thing. Got a red line here, self. And also don't put a semicolon, put a full colon because it's an if statement. We want to do self.current game state equals game state dot game over. So if hit the wall, it's game over. Let's try it. Bam. Look at that. It crashed and stopped. We can start again and the wall's still good. Bam. So now we can collide with the apple, we can collide with the snake, we can collide with the walls. That's all the collision detection we need to do. What else should we do? We've almost got a full game. I think we need some scoring. Right. Game's not fun without some score. Now, because we want to write a bit of text to the screen, there's a fair bit to it. So I want to just create a class to do it so that we keep our draw function fairly tidy. So up above our class app, our app class, remember to leave enough space. I'm going to create a Hud class that's going to draw our labels and scores and whatnot. Let's give it a comment, hey. Hud class handles drawing text and scores. So init. Now we want to put a title on here as well. So title text equals, calling it nibbles. Now we want to put X and Y coordinates for these things as well. But we want to place text kind of dynamically, so you can't see my mouse cursor. So I want the title to be centered along the top. I want the score to be on the right, and I want some other stuff on the left. And to calculate all of that, we're going to use some functions. And I think we can just put the functions inside the HUD because we don't need them anywhere else. So we want a helper function for calculating the start X value for centered text, def centered text. It's going to want the text that we're talking about, page width, character width equals pixel.font width. We can just set that to a default. We're just creating a general helper function here. We can use that in other games and whatnot as well. So we'll make it a little bit generic. All right, so what it's going to do is take the text width, this is what we're passing into it, equals the length. Sorry, this is a temporary variable. We're going to set as the length of the text that we passed into it times character width. And then we're going to return page width minus text width divided by 2. Method center text may be static. Make function from method. Yeah, I thought it might do that. All right, so instead of putting it in the HUD, let's just put it outside of the HUD. It's static. It doesn't need to make changes to any of this stuff. We'll just stick it out here. It's a helper function. We can use it for everything. It stole our comment though. Sorry for that confusion. Let's put it out there, flapping in the breeze. All right, so back in our HUD, we want title text X equals center text self dot title text, and then the width of the screen is 196. You want self dot score text equals, we're just going to start it as a string of 0. Score text X equals, now we're going to need another helper function here. Oops. Function for calculating the start X value for right aligned text. Right, so def right text, it's going to want the text, the page width, and the character width, which we'll assume is just font.width. It's going to do text.width equals the length of the text times character width. It's going to return page width minus text. Hang on, I put a dot there instead of an underscore. Sorry about that. Text underscore width. There we go. Did you catch that? Were you screaming at the screen? Plus character width. Okay, so page width is the right-hand side minus the width of the text plus another character. Otherwise, it's kind of off the side. All right, so score text X is going to be right text self.score text 196. Cool. Now we're going to put this in here. Level text. That's a prompt for you guys to make the rest of the levels for this game. It's going to tell you what level we're on. Level text X. We're just going to put it, it's going to be on the left hand side. And I know that it wants to be 10 pixels in, so just set it at 10. We also want to keep track of how many apples we've eaten. Self dot apples text X equals, here we go, the length of self dot level text. We want to put the apples text right next to the level text, but the level text might grow as the levels grow, so we need to calculate it, right? Level text times pixel dot font width plus self dot level text X plus another 5 pixels. Now we're going to want some draw functions in here. So def draw title. We could do it in just one big draw, but I'm going to put it in separate functions so we can call them individually, and it makes it easier to add things. Now, if we just put text straight on top of that white background, because our white background's got those lines in it to make it look like tiles, it might obscure the text a little bit. So what I found is if we put a rectangle behind it, it's the colored rectangle, it stands out better. And we'll make it a little bit bigger than the actual text. So that's why I did -1 there. So it goes 1 pixel bigger to the left. Self.title text times pixel.font width plus 1. And then, so a rectangle is, it wants the X and Y coordinates. So the X is that, the Y is that, and then it wants the width and the height That's the width. Now we're going to do the height. Will be pixel dot font height plus 1. And we're going to make it color 1. Got a typo there. Fixed him up. Remember, you can just hover over the function to get an idea of the parameters it requires. Right, so that'll draw a rectangle. Now let's draw the text. Pixel.text self.title text x. So it needs the x and the y coordinates. We're putting it 1. Then it wants the string, title text. Then it wants the color. Let's make it 12. Now before we add these other ones, let's put that in the draw function. Let's make our app happy again. Draw. Now I want the titles to draw on top of everything else. So even if the snake crashes into the top of the wall where our text is, I want the text to be above it. And before we can call that draw, we need to actually instantiate it here, remember? So we've got level, we've got apple. Let's put it after level. Self.hud equals hud. Now down in our draw function, back where we were going to work before, we go self.hud.draw title. That should at least give us our title on our screen. There it is. It's got a nice rectangle in the background so to make it stand out. And our snake should be able to crash into the wall still, but not obscure the text. Nice. Let's go back up to our HUD and finish typing out our rest of our titles, or the rest of our text thingies. Now we're not tracking score at the moment, but we're going to start drawing the score so that when we do track it, we'll see it straight away. Draw score. We're going to have to give it the score so it knows what to draw. And we need to set it to str score. And we need to recalculate the position. So title text x equals right text self.score text 196. That's the width of our screen. Then we want our rectangle. Let's steal it from up here and then just modify it. Now, because we're doing score text, take out these title texts. Hold up, I typed the wrong thing in here. Look at this, title text. We should be doing score text. Nice, good catch. Did you guys see that? Right, so rectangle is going to be based on score text. That should be right. Now we do a pixel.text self.score text x minus 10. I want to move it over a little bit more so it's in line with the top tiles rather than hanging over the side wall. You know what I mean? And because the rectangle is one bigger, we need to make that 11. So 10, 1, self.score text, color 3. Nice. Def, draw level. Pass it the level. Self.level text equals level plus str. We need to convert levels an integer, a number. We need to convert it to a string before we can concatenate it onto the end of that string. Then we're going to want our rectangle and our text. Let's copy those and then modify them. So remember, we want level text. Level text. Let's change every instance of score text to level text. Now the location of it is going to be sweet like that. One more. Draw apples. This is how many apples you've eaten. Apples text equals apples plus stringify apples. Paste these bad boys in again. And we're using apples text. Underscore X. The location is correct. And we're doing color 8 for that one. So let's go down to our draw. And let's go self.hud.draw level. Self.hud. Actually, we can't do level yet because we don't have a variable for that. Self.hud.draw score. We don't have that either. Let's just put a 0 in there just to test it. Come on. There he is, up in the corner. Let's create these variables real quick while we're thinking about it. So in our app constructor, down here, after our time stuff, let's do the score, eh? So self.score, initialize it to 0. Self.apples eaten this level equals 0. That's something for you guys to deal with later in your homework. Apples eaten this level. I want you to make it so once you've eaten so many apples, that'll trigger the level change, so you'll load the next level. It's alright if you don't feel like doing that homework, it's cool. Or if you're not sure what to do, come and ask for help. Come along to forums.caf.tech and ask questions there. It's also a good place to keep track of my other projects, other things I'm doing, ask questions or recommend videos. Apples eaten total. That's what we're going to base that thing on at the top of the screen. And we also want self.current level, starting at level 1. So we've got score, apples, level. Now back down to our draw function. Let's actually draw the score. Oh, self.score, sorry. Self.hud.draw level. Self.level. Self.hud.draw apples. I'm going to use apples eaten total. Alright, so now we should see all of those things. By God, it's horrible. What's happened? Level, so there's something wrong with the level. See that? It's showing an object instead of that text. Level is level, that's wrong. Current level. Current level. See, because up here, level is our level class for handling, drawing the level and loading stuff. We wanted current level. Did you guys notice that typo? Now if we run it, it's looking nice. Score, we've got a title, we've got our apples eaten, and we've got our level. Now let's start incrementing those numbers. Where should we do that? Actually, before we do that, we need to update our start new game because we've added some new stuff. When we start the new game, we want to reset the score and the apples eaten and the level and whatnot. Right? So let's copy those. Let's put it under the time stuff. There we go. Nice. Now, in our update function, after we've checked for collisions, let's update the score. Self.score plus equals. Now we're going to base the score on the length of the snake times the number of apples eaten plus 1, just to get him started. Length of the snake, self.snake, times self.apples eaten total plus 1. I'm putting that plus 1 there because apples eaten total starts at 0. So he won't get any score until he eats the first apple then. So we'll kickstart him with 1. That way he'll start getting score the minute he starts moving. Now, for that apples eaten to increment, we need to come down to our collisions, right? And when we collide with the apple, as well as moving it and changing the speed and increasing the sections to add, we want to go self.apples eaten total plus equals 1. We'll do both of these apples eaten plus equals 1. There we go. Now let's try our game. Score increases, the apples increases. If you watch the score, it should increase at different rates after we eat apples, because our snake's getting longer and the number of apples we've eaten is increasing. Nice, and if we hit enter now, it should reset the score and the apples eaten. Yeah, nice. Awesome. Now let's get rid of that debug thing down the bottom where it says game state running. Remember we put that in the bottom of the draw function? Here's our draw. It's up here. I'm actually going to comment that out just so we can come back and use it some other time. Let's just do one little tidy up here. We've got a warning, probably about not enough space. Yeah, 2 blank lines, that old nugget. That old chestnut. All right, we've got a green tick. It's complaining about a typo in the word Pyxel here. Let's just add that to the dictionary also. There we go, green tick. Now, the next thing we need to do, sound. That's the last thing we should do in our game, I think, before we pass it off to homework. So back in our resource editor, we've got sounds and we've got music. We're going to create some sound effects here. Now, the piano keys here indicate where you can make sounds. There's tone effects. You can set the volume for the notes and you can set the effect for the notes. If you have a look back at this page here we left long ago, down at the bottom, we've got audio, we've got image class, sound class. And that gives you an idea of the types of tones and effects you can use. So tone can be triangle, square, pulse, or noise. Volume can be between 0 and 7. The effect can be none, slide, vibrato, or fade out. You can also set the speed. All right, now let's build a sound for picking up an apple. What do you think that should sound like? Let's press some things and see what it sounds like. Oh, there we go, I'm going to play it. If you click on the keys, you can hear the sounds. So that's a pretty horrible sound. Let's make it pulse. Oh, there we go. Sounds horrible. Now, what can we do? Let's put fade on it. Now let's change the speed. Make it a bit faster. What else can we do? Square, pulse, noise, fade. We'll try square and noise, see what they sound like. So instead of pulse, let's go square. Alright, noise. Wow. Stick with pulse. Let's make it like that. Let's try and fade the last one. So if you want to fade the last one, you can put null, null, fade. No, I don't like it. Alright, that can be our Apple pickup sound. Now, sound 1 can be our crash sound. So for that, let's use noise. What can we make for the noise? I don't want that one there. I think I can. Yeah, you can delete it. Let's put a fade on it. No, let's put null, null, fade. There you go. Little crash noise. Nice. Save it before we lose it. Now our music, we can only use the notes that we've already created to make our music. Now I'm no musician, so get ready for some garbage. Now I think I want to use 2 channels. I have a bass channel, have like a bass line, and then some sort of melody. So let's go down a bit. Let's make it pulse down here. Is pulse what we want? What are the other ones? Square. It's very harsh, the square one. Let's go with pulse. Let's put it lower. Ooh, that's pretty deep, eh? Dirt. So let's go dirt. Dirt, 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 dirt. And then if you want to put a gap, you can put something down here. All right, there's our little looping bass line. Let's put it along here. I think we can just click on them. 4, 5, 6, 7, 8. That'll do. Now let's create another sound. This will be our melody. What can we do for that? What's this one sound like? And we want to put gaps at the end. Change it to pulse. No, it sounds like crap. Alright, let's try and add that to channel 1. Put 2 of those. Now, if you want to leave blanks here, you can't just put... Oh, you can put blanks. What does that sound like? Play it. Now, see what happens when you put these blank ones here? You actually have to come back and make a blank sound. So I'm going to make number 4 a blank sound, and to do that, we use this bottom row here and just put those blue dots all the way. Right, so 4 is that blank sound. Here we go. There you go, you like my crappy tune? Let's add it to the game. Now, up in our app class, let's create, and because that music's going to become grading pretty quickly, we want to be able to toggle it on and off with a key, right? So let's create a variable called play music. And we'll say true to start with. And then we go if self.play music, then this is how you call a music track. Pyxel.playM for music. It's music 0. Loop equals true. Play music track 0. Now we need to do that in our start the game function also. Do that last. So if, we'll just copy this here. Blam. Now in our, let's create a function to toggle the music. Let's just put it here under update, hey? So def toggle music. Self.play music. So if play music, then self.play music equals false. Pyxel.stop. That tells Pyxel to stop playing all sounds. On all channels. Else, self.play music equals true, baby. And then we're going to call that this again, just to fire it up again. Blam. All right, and our input, we're going to put a key in for that too. So under our game over stuff, let's go if. Now we're going to do it slightly different here. We're going to go Pyxel.button P. That means if the button was pressed this frame, not is it held down. Pyxel.key, let's call it M for music. Self.toggle music. All right, now while we're in here, before we test it, we want to go to our check collisions. That's where we're doing the rest of our sounds. Check collisions. Now if you collide with the apple, let's start playing the sound. Pyxel.play. Which channel we're going to use? Let's use channel 3, the last channel. Sound 0. Play sound track 0 on. channel 3, Apple, pick up sound. Now, if you crash into yourself, Pyxel.stop. We're going to stop all sounds if you crash, and then we're going to just play the crash sound. So Pyxel.play channel 3, sound 1. Play sound track 1 on channel 3, crash sound. And then do the same thing if you crash into the wall, right? Bam. Now let's try it. M turns the music off. Sound still works. We get the crash noise. And you can start the music again. There you go. Now you've got a fun little game. Hopefully you made better music than me. You can make it as long as you want. If you look in this thing here, for each channel you get all of these bars here, and each sound you can make them that long. And you can use a ton of different sounds. I can't remember how many. And you've got, if you keep your sound effects on channel 3, then you've got 3 channels to use for your music. So your music could be a lot better than mine. If you do make something cool, I'd really like to see it. That'd be cool. If you come onto the forums, you can post your work there or throw it on GitHub and post a link to it there. That'd be cool. That way I'll get to see your sprites, your apples, your sound effects, and your music. Now, ways you could improve this game is we should have a game over screen. So when you crash, it should come up on the screen, game over, press enter to try again. Maybe we should have a title screen, something comes up when you first start the game. We obviously need more levels, so you could build a way to load the next level. And it's up to you, whatever else you need, you feel like you want to do. Change the sprites. Maybe you could have more than one thing to pick up. Maybe instead of just picking up apples, you'll also pick up coffee cups. Well, that concludes our Python tutorial using Pyxel to create the snake game. Hopefully I managed to teach you something here. Now, if you had trouble with anything in this video, you can come along to my forums at forums.caf.tech, post some questions in there. Someone will come along and help you if I don't get there first. I'd also like to see your versions of the game with your sprites and your sound and your music, so come along and post them in there. If you'd like the source code for this game and you just want to steal my resources and not be creative yourself, after this video I'll upload them to my GitHub page, github.com/caffeinatedtech. I'll create a new repository called Python Nibbles. Here's the forums while we're here. I've been doing work in C++ and Python and Godot, and I've been mucking around with the VIC-20, learning assembly language for C64. I hope you enjoyed this video. I hope you found it informative and useful. Thank you very much for watching. If you wouldn't mind, give that subscribe button a tickle. Throw some comments in the comments section. Let me know how badly I did. And if you're able, your support on Patreon or Ko-fi is greatly appreciated. Thanks, guys. Stay caffeinated.